Hey guys, welcome back to my channel. In today's video, I'm going to show you how to construct a discrete probability distribution based on a particular experiment. And hopefully after today's video, you will have a very intuitive understanding of what probability distribution is. Without further ado, let's get into the video. Okay, let's talk about probability distribution. So probability distribution is for a variable. So when you hear people saying probability distribution is normal or is binomial, that means a variable follows a particular distribution. So that's, if I write it more completely, that should be probability of a variable. The variable means something you're interested in can take on different values. Okay, now let me write it here. So variable. Things you are interested in can take on different values. So in order to obtain the values of this variable, you need an experiment, right? You need to run an experiment. An experiment in econometrics or in statistics means a process that leads to one of several possible outcomes. So it's a process that you can observe and that can give you more than one possible outcomes. The experiment could be you flip a coin once. That could be an experiment, right? It's a process that you can observe, and this experiment can give you, this process can give you more than one possible outcomes. And then you can get some outcomes. You flip a coin once, and you might have a head, right? A head showing face up. And you run the experiment again, and you might get a tail. You run the experiment again, you get a head. Again, you get a head. Again, you get a tail. If you run this experiment so many times, an infinite number of times, what the probability they observe tail, observe head, you know that because it's classical probability, right? So a fair coin, you flip a fair coin, the probability to observe head is 50%, and the probability to observe tail is 50%. But now the variable is something you're interested in, right? After running this experiment. So I suppose the thing I'm interested in is number of heads. Number of heads observed, or a number of heads showing face up if I flip a coin once. Okay, and now you can collect the data for this variable. If you observe a head and then that value of this variable is 1. If you observe tail, the value of this variable is 0. If you flip a coin once and run this experiment again, and then you observe head, 1, 1, 0. Right, that's the values that this variable can possibly take on. And then in order to get the distribution of this variable, you just need to organize this data in a table or in a graph. Okay, we can say we organize the data into a probability distribution table or a probability distribution graph. Now the probability distribution is, let me just call this variable x. Okay, you have this variable x. So, and here you should write the values of the x can take on, or all the unique values of x. So we know 1 or 0, either 1 or 0, based on this experiment. So we have 0 or 1. And now the probability is here on the second column. So what the probability to observe 0 and what the probability to observe 1. And based on our knowledge, we know that this is a classical probability. The outcomes are equally likely to occur. So the probability that x equals 1 is a half, or 50%. And the probability that x equals 0 is also 50%. And you see, total, you get a 1. So that means they are exhaustive. So you didn't lose any values, or didn't lose any possible values of x. Okay, and this is called a probability distribution for this variable x based on this particular experiment. We call this tabular display of probability distribution of the variable x, the number of heads showing face up based on this particular experiment, which is flip a coin once. And you see, if you know the probability distribution of this variable, we say you have complete information about this variable because you know all the values this variable can possibly take on and the probability that x equals any value. Okay, and normally we like to visualize this table. or visualize the probability distribution, we want to have a graphical display of this distribution. So we can draw like this. This is the probability on y-axis, and this is x, this is a variable. The values x can take on will be 0 and 1. And now the height of the curve showing the probability. So this is a half, and this is another half. And this would be, this is a half, and this is another half, 1/2. And this is a probability distribution in a graphical display. So probability distribution for the number of heads showing face up when you flip a coin once. Okay, that's probability distribution for x. You know the value of x could be 0 and 1, and also the probability x is a half and half. Here, x is a discrete variable. Okay, you know that it's discrete. Discrete means it is not continuous. We call it discrete random variable. So there are gaps between values. You can have 0.5 heads or 0.3 heads. There are gaps between values. This is just use discrete random variable to show you this intuitive understanding of probability distribution. First, you need to have something you're interested in. In order to get the values of something you're interested in, you need to run an experiment. And then once you collected all the values of this variable, you can organize all the values into a probability distribution. Okay. Probability distribution gives us all the values of the variable and a probability that x equals any value. And here x is discrete. Okay. So next video I might give you another experiment, and I will show you how to construct a probability distribution based on different experiment. Yeah, this is today's video. Hope you find this helpful. Any questions, comments, please let me know. And the next video, as I said in the video, that I will do a different experiment and construct a probability distribution for the same kind of variable, but based on different experiment. Yeah, stay tuned and see you next time. Bye.